Hello and welcome to our online classes, and today we'll do number system, and in this particular video you will learn how to identify rational and irrational numbers and what to write in exams so that you get full marks. But before we go ahead, let's understand the concept here. The concept is the definition of rational and irrational numbers. A rational number is any number that can be expressed as a fraction where both the numerator and the denominators are integers and the denominator is not zero. This can be written in such a way that you have any number can be written as p by q form where q is not equal to 0 and both p and q should belong to integers. Let's understand the very tricky irrational number definition. An irrational number is a real number that cannot be expressed as a fraction of two integers, that is, it cannot be expressed by p by q form where q is not equal to 0. And in general, how to identify them is, in decimal form, irrational numbers have infinite non-repeating decimal expansion. That means it will be a non-terminating thing, plus the numbers will not recur. Okay, so let's identify some of the numbers that I have chosen into rational and irrational number. So the first one, as you can see, it is 2.353535. Okay, so just erasing this particular dot. Now what you have to write? So you can say it is terminating. So first, as you can see, there is no dot dot, so you can say it is terminating and recurring decimal number. Therefore, it is a rational number. You can say by definition it is a rational number. Okay, make sense? So let's go to the next one. 0.6 bar. So this can be written as 0.6666 and dot dot dot. It is non-terminating, obviously. It is not ending, but it is recurring number. Since the 6 is repeating, therefore you can write, therefore it is a rational number. Okay, makes sense? You can write by definition it is a rational number. So let's go for the next one. 2.236067 dot dot dot. As you can see here, it is non-terminating first of all, repeating, and if you see, there is none of the numbers which are getting repeated. This means the number series will keep on going, and non-recurring. So by definition of irrational numbers, or you can just write, therefore it is an irrational number. So make sure your definition is very, very strong. Therefore it is an irrational number. Okay, I hope that is clear. Let's go to the next one. Now, a root number, a classic definition, a classic example of irrational number. But how will you write this? Let's say you have root 7 by 1. Okay, this can be written as p by q, let's assume, where p in this case does not belong to z. Okay, where q belongs to z. Okay, so the 1 belongs to z, root 7 does not belong to z. So you can say root 7 does not belong to z or integers. Therefore, root 7 is not a rational number. Sorry, I wrote extra. Therefore, it is an irrational number. Okay. So any root which does not have a perfect square, you can write in this particular fashion and you will get full marks. Now, very interesting and very famous. We have E. Now, E is also known as Euler's number. and in general it is written as 2.71828 and dot 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 and so on. Now as you can see, it is non-terminating, non-recurring decimal number. Therefore, as you can see, by definition, non-terminating and non-recurring is a definition of irrational number. So therefore, it is irrational number. And for general knowledge, just remember, E is an irrational number, pi is also an irrational number. But how will you prove this? This is how you should write in the exam. Okay, another very famous and the most important number ever, we have pi. So if we have 3.14159. So how will you remember this case? So you can remember 3.14 dot dot dot. You can do that also. That is also okay. So you can say dot 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 over here is a non-terminating, non-recurring decimal number. Okay, therefore it is an irrational number. No. Okay, cool. So let's go to the next one. Don't worry, we have only 10 examples, so we are almost ending. Now 5 plus 7. So you can say 5 is rational number. Okay, that means pi can be written as pi by 1, which is p by q form. Both p and q belongs to z, and q does not, q is not equal to 0. Okay, so there's no problem with the 5, but root 11 is irrational number. Therefore, you can write root 7 can be written as root 7 by 1, which is equal to p by q, where p is root 11, q is, which is not equal to, since, okay, I will write root by 1, let's say p by q, p is root 11, q is 1, p, that is root 11, does not belong to z. Okay, this belongs to z. So therefore, you can write, so I'm writing over here. Okay, I'm writing over here. Pi plus root 11 is an irrational number. That is a combination of a rational and irrational number will ultimately be an irrational number. Okay. Thanks for listening till now. And if you're following this particular video, just like, share and subscribe. Share it with your friends and apply this method in your exam so that you get full marks. Okay. Now understand, same way, root 3 is irrational and you can prove it now. Root 13 is also irrational. So a combination of irrational number with an irrational number is an irrational number. Okay. Here I am writing proof using above method. Okay, so therefore we have root 3 plus root 13 is an irrational number because the combination cannot be expressed as p by q form. Let's go to the next one, a fraction. So in general we have, okay, now 15 by 4 can be written as p by q. P here is 15, which belongs to z, that is integers, and q is equal to 4, which also belongs to z and which is not equal to 0. So therefore 15 by 4 is a classic example, is a rational number. Okay, that makes sense. I hope you're understanding. And so this will be interesting. So they might give you something like a combination like this. So in this case you have to prove that using formula. This is a minus b, a plus b. So using a minus b, a plus b, we can have a square minus b square. So that is 2 square minus root 2 square. As you can understand, 2 square is 4 and root 2 square is 2. So this answer is 2, which can be written as p by q. 2 can be written as 2 by 1 can be written p by q, where p is equal to 2 and q is equal to 1, and both belongs to integers. Therefore, now understand, here you will not write 2 is the rational number. You will write the whole thing. You will write therefore 2 minus root 2, 2 plus root 2 is a rational number. Okay, so that's it for the day. I hope you understood how to write, how to explain whether a number is a rational or irrational number. In the next episode or in the next video, we will learn how to draw an irrational number, that is a root number, on a number line. Okay, so if you like this video, please make sure you like, share and subscribe, and share with your friends. Thank you. See you in the next video.